Okay, this is the second time I've shot this. The first time I shot it was outside UQ this evening and got the footage at home and listened to it, and there were thousands of birds roosting in the trees, which I failed to notice for the first time I recorded this. But anyway, okay, so I'm here to talk about a university project I did over summer. If you're not a pretty serious archaeology type, and also not a pretty bit of a geek, you're probably going to find this incredibly dull. This project was designed to determine if you have all your archaeological data on a site in the field going into a database, and you visualize that data. Will it help you detect errors in the data? I've been on a few sites where there's been really simple errors that have been made, and when you've come to look at the data, you've suddenly noticed that artifact is outside your trench. I've seen this happen, and I thought, all right, well, what can you do about it? And this project's really a bit of that. I'll explain how that all works in the video. This is the video that I handed in to my professor to sort of explain everything. I handed in a big chunk of code, I handed in my essay, and I handed in this video. I think more important than this essay and this topic is a realization that I came to in the process of doing this project, and that was that a lot of computation can be done in the field automated, like completely hands-off. Like, as long as you got people recording data into a database, you can do a lot of the analysis in real time on the spot and have it there ready for you to look at. So things like, cluster analysis, or you have the side profile of the trench and see all of the artifacts in the different layers and the different types. You can have these publishable quality in your hands before you get back to the lab. All of that sort of month of, 2 months of, mucking around with data when you get back to the lab, why not get back to the lab and you already have your full set of GIS files completely broken down? That's really what came out of this. And this project is really sort of a prototype of that. It's like a proto in the field analysis tool. But this only does a small part of it. All it does is just renders the data in 3 dimensions. It was a bit of a nightmare. I mean, there's lots of technology in play here. There's multiple 3 operating systems, Android, Linux, and Windows. There's a host of technologies, including Blender, which is an animation tool, and Python. I had to muck around a lot with splines to circle around the archaeology. I had to muck around with transparency of context layers so that you could sort of recognize that a context layer was there, but you want it sort of semi-transparent so you can see through it. A lot of calculations on working out the center of a cluster of artifacts. So all of this went into this research, and I think it came out pretty well. I'm sorry this is a bit of a long video. There's no escaping it. If we're going to geek out together, the geeky videos are going to be a bit long. In fact, all my videos have been a bit long lately. I think I need to trim them, but I can't trim this one because this one is long by nature. So here we go. I hope you enjoy it, and leave a message in the comments. Here's my summer research project. Bye. Hello, I'm going to show you the visualization tool I've created and how it works. So we have here, it sits on top of a FAMES archaeological database system. So to give you a quick rundown how that works, we have here some archaeology. We have a Android tablet running the FAMES app, and we have a FAMES server. This is all pre-existing technology here. So the archaeologist records the archaeology into the app, and the app syncs with the server and stores its data there. Everything over here in orange is what I've created. So I have a Windows 10 rendering machine, basically. And the way this works is that a Python control script logs into this Ubuntu FAME server, launches this Python script which extracts the data out of the FAME's SQLite database that it needs, and it creates .object and .shape files. Those are then picked up by another script which renders those in Blender, the open source rendering animation tool, outputs some AVI files which are then run in VLC and are displayed to the archaeologists on site as an information radiator. So take a look here. So we've got the tablet, the server, and the Windows 10 machine, and that is exactly what we've got here. We've got the Android tablet being emulated or virtualized. We have the FAME's Linux server here, and we have the Windows 10 render box going on here. So it's doing its job right now. It has collected data from the FAME's server over here. It's collected data from over here. It is rendered it in Blender and displaying it here. It has used the convex hull algorithm in order to create meshes for each context. So any spatial points that make up a context are rendered as sort of a triangulated mesh here, and they are given labels with defining what they are. Samples, any points, spatial points that were samples are rendered as well in green, and coming around the back here in blue are finds. Okay, so what we're going to do now is we're going to enter a new point, and it's going to be a point that is accidentally entered in error, to see whether this visualization tool can in fact help detect these errors. So what I'm going to do is go over here and go to, this is the Android FAME's tablet, which is talking to our FAME server over here. So what I'm going to do is go to context. Okay, and we're going to enter a new artifact. Add artifact. Okay, so we're going to call this artifact. What have I called the other ones? I think I called them art. I did. Art 4. Yep. The art 4, and it is a, let's say it is a piece of ceramic, and let's give it some cool, let's give it a description. Call it Lapita pottery shed, and we'll give it some coordinates. Let's give it some coordinates outside. Now let's do this. 7.1, 0.25. Okay, so we're giving it coordinates now, but I'm going to make a mistake. These coordinates would be inside the area of the context, inside the excavation area. But let's make a mistake. Let's do a common mistake. Let's mistake a 7 for a 1, and enter that. And let me see. Have I finished everything I need to do? All right. So that's entered. Okay, there we go. Now it's a waiting game. Right now, behind the scenes here, this is currently re-rendering all of the data we have to what we have to do is wait for that render to complete. Then it will start the loop again, pick up this new data we have just entered, and display it over here. And we'll see if the error is detectable easily or obvious. Okay, so what we need to do is we need to come back a little later. Okay, so we can see here the rendering has now been updated and it is complete. And you can see that just around the outside here, there is the new data point we entered, art4 for artifact number 4. Now, when it swings around in front of the camera here, you can see that it's sitting outside the context, which is an indicator that it is there is something wrong with its coordinates when it was entered. And that's pretty much it. That is the tool. Thank you very much. By the way, that's UQ back there. Pretty, huh?